This is okay. Hey guys, I'm Eric. This is my colleague Anthony.
Hey guys.
We both work on the analytics platform team at LinkedIn, and we're going to talk about how we balance data democracy with data privacy. Our friend GDPR might show up in this talk as well. So I joined LinkedIn about a year ago, and I think one of the first things I learned when I joined the data org is that one of our goals was kind of enable data democracy. So our kind of primary customers are LinkedIn data scientists or analysts, and what they do is look at member data, provide insights from it, and kind of feed it back to the site. So for example, people you may know, jobs you might be interested in, that kind of thing. And if I have my data scientist hat on, I want a couple of things, right? I want to analyze as much data as possible because I want accurate models. I want to discover any new data that's around as fast as possible because I might want to suck in more things to again, build better models. And I also want to access data as fast as possible. I don't want to have to talk to a data engineer. I don't want to talk to some security person. I want to kind of quickly and easily get access to data when I want it. But you contrast that, as a LinkedIn member myself, I kind of want my personal data to be stored only where needed and not propagated across 27 different hard drives because the risk of a breach is much higher. I want my personal data to be deleted when I close my account or request deletion. And this is actually a kind of, the right to be forgotten is enshrined in the new GDPR regulations, and I think it's always been an EU kind of tenet. And I also want my personal data to be processed only if essential and only if I consent. So I don't necessarily want my data being sent around and processed for any random reason at all. So we have this kind of paradox, right? The scientists want more data. They want to discover everything out there, and they want very easy access to it. As a customer, I kind of want less data. I want to discover any governance where people are using my data without my consent. And I also want to make sure it's restricted, again, for only business purposes. I'm happy with my data being used for some purposes, but not anything out there. So let's talk about how we deal with data at first. So a quick information about the LinkedIn data ecosystem. I think people may have seen some of these slides before, but we have a large number of Kafka topics and data, from generated from what people do on the site, generated from database change logs, things like that. This all gets ETL'd into Hadoop. And then we also pull information not only from Kafka, but a large variety of other data sources: Salesforce, random REST APIs, could be MySQL, could be Oracle, and things like that. And Goblin powers most of these arrows. That's actually why we built Goblin in the first place, to kind of standardize all these movements back and forth. So I talked before about the right to be forgotten, or the right for erasure. I think this is, I don't know if this is a direct quote from GDPR, but one of the things we want to do is delete all my personal data without delay, or when I no longer consent for it to be used. Translated to the analytics platform team, that means we'd be able to delete some subset or all data associated with the user when they ask for it. And this could be in Hadoop, it could be in Kafka, it could be in Oracle. It's across the LinkedIn ecosystem, although we're going to be focusing mostly on Hadoop today. So why is that hard? So, one thing is it means that we have to understand all the data that's on Hadoop. There's kind of, as you saw before, we have data from a large different number of sources. It's generated all the time. The data platform team might not necessarily know it's there because a lot of the times Goblin and other tools are built to be kind of data agnostic. We need to cycle through a large amount of data, and we need to do that without affecting other running jobs. And then we also, sometimes we need to do a quarantine record. So if we're not sure if this record belongs to a member, or we want to make sure we're not deleting too much, we want to make sure we have the ability to kind of soft delete data in a sense, and then hard delete it later. So you guys just heard the talk about all the Goblin pipelines and converters, so I'm going to skip this part. But logically, a purge job can be thought of as a fairly simple conversion task. Or high level, it's very simple. You get in a record, you say, hey, you can have a list of all the members who want to delete their accounts. You say, hey, is this record pertinent for one of these members? If yes, delete it and return no rows back. If no, just return the row as is. Of course, it's not that easy once you implement this feature, but it's very straightforward from a kind of 10,000-foot view. So, and Anthony's going to talk a little bit more how we implement that in depth right after this. But I think one of the problems we've had is, and we have not figured out the solution, is that we have to go scan over all of our data, and we have probably hundreds of petabytes. We scan hundreds of terabytes a day, and then kind of constantly read this file in, purge it, write the file back out, and we know it's going to cost a lot of heavy disk I/O. I don't think we've figured out a solution to this problem yet, so if anybody has one, we'd love to take advantage of it. So the next one is talk about how do you discover data and how do you deal with data governance. So LinkedIn, again, has a bunch of different data systems all over the place. Databases at rest, we have things in Kafka, we have things on Hadoop, we have derived data stores. Many of these are open source, but there's data in a variety of places. And again, as a data scientist or even as a security person, you might want to know, hey, where are all the data sets on our system? Where do they live? Is this in Kafka? Is this in Hadoop? Is this in someplace else? How did it get created? How long has it been around? Things like that. And we built this tool called Warehouse for this, and Warehouse is open source. I think it was open sourced last year, I want to say. It was originally designed to be primarily for data scientists to help them discover data. We've been expanding that, and I'll talk about that. You can find our GitHub. So you can see a few screenshots, but essentially it lets you, we index a bunch of data sets, and we also provide metadata on top of those sets. So for example, Warehouse can go in and figure out what is the schema of this data set, what's some documentation associated with it. We talk about data lineage, so where does the data set come from, who reads it to produce other data sets, things like that. Sorry, these screenshots are really small. But yeah, after you look at this from a security standpoint, there's other metadata that's very interesting from a data governance perspective. Which data sets have PII in them? Which data sets have member-to-member messaging data or other highly confidential pieces of data? Who can access them? When were they last accessed by who? Have they been purged in the last 90 days, or what other our requirements are? And the reason, and this is very interesting, and the reason it's a hard problem is with our data diversity, we have 20 different data systems, many different data formats, ORC, Avro, native database formats, could be other just custom formats. And we also want to understand more than just the schema. Understanding that you have 6 fields that are strings is not really enough. You have to understand the semantics. So Warehouse, kind of from a 10,000-foot view, has a bunch of different components. It can go out and scrape metadata from various sites. So it can go out and crawl HDFS and discover data sets. It can crawl your MySQL database and describe the table and pull out schema. It also will listen to event logs and things like that and pull in metrics about who's accessed this data set. This basically gets all stored in a centralized repository, and then with a combination of kind of human notation and machine learning process, it can decide this field probably means it's somebody's first name or it's somebody's last name, things like that. And then under the hood, it gets a little bit more complicated. But that's the idea, and we're kind of extending Warehouse more and more to power our metadata-driven features. And I think a lot of these have been contributed back to open source. I think more will come, probably in the next few months to come. But it's very powerful. I think the transition to metadata kind of driven data management has been, I think, a very interesting thing that we've been focusing a lot on in the past couple quarters. And I'll hand it over to Anthony.
Thank you, Eric. Hey, everybody. My name is Anthony, and I work on the data management team at LinkedIn. The data management team consists of the Goblin team plus the DALI team. I'll explain what DALI is later on, but it's our data set access layer at LinkedIn. And I'm going to talk to you about the last part of the data paradox, which is how do you balance giving everyone access to the data versus protecting members' privacy. So, let's talk about some of the requirements. Of course, everybody wants access to all the data, especially analysts and data scientists. But, to protect members' privacy, it only needs to be shared on a business case basis. And by default, we don't want to make all of our data sets world readable. A lot of aggregations and metrics can be done on the obfuscated data as well without having to expose people's personal information directly. And finally, we give users a lot of privacy controls on the website. If they tell us that they don't want their data used for ads targeting, we need to respect that. So let's take a look at how we do that at LinkedIn. And just like all of you guys, we use a wide variety of frameworks here. Pig is probably the most popular framework at LinkedIn. Spark is probably the second most. It's growing in popularity. And of course, there are a lot of people using Kafka and Samza, which are both Apache projects that started at LinkedIn. And then you have SQL users using Hive and people using Scalding. So we have a lot of frameworks, and that's great for our engineers and data scientists. They can pick the favorite tool, they can get up and running very quickly. But it poses some challenges for us. every reader, every framework has their own custom Avro reader or ORC reader. And they're directly accessing HDFS and accessing specific file paths. So that makes it difficult for us to evolve our data format to something else. One option is to duplicate all of our data in multiple formats, but with dozens of petabytes of data, that's just not economical. But this direct dependency also poses some challenges for the analysts and the users themselves. As you guys know, business needs change and data models evolve. And tomorrow, we may introduce version 2 of some ad click event or some page view event. And then there are hundreds to thousands of scripts that you need to update to include these new data sets. And doing these migrations is a pain and is a big tax on a company at the scale of LinkedIn. So to solve these problems, conceptually what we need is to build an abstraction layer on top of our data that users use. We need the ability to kind of manage each data set independently and evolve it independently, without requiring migrating thousands of scripts. And you can think of this sort of like in the online world, you have services that are deployed and upgraded independently of one another, and users just depend on their REST APIs. So at LinkedIn, the way we solve this is by building DALI, which is the team I work on. And DALI is LinkedIn's dataset access library. And its goal is to hide the underlying physical details like the HDFS path and what format it's in. And we want users to only think about what the logical dataset name they're reading is and what its schema is. So we've built a bunch of data set readers here for accessing data, as well as tooling that lets users manage and evolve their data sets. So to dive a little bit deeper, the experience at LinkedIn working with dataset looks something like this. As a dataset owner, I will define a dataset using some SQL. And that can involve include SQL transformations. It could apply custom user-defined functions that do business logic. And I check this into Git, so it's tracked and it's versioned. And we have internal tooling that publishes each version to our central jar repository called Artifactory. Once that happens, we have automated tooling that deploys this to our data catalog, which is the Hive Metastore. So we have all of these tables and views registered in the Hive Metastore. And these are the DALI datasets that users can now consume. And they can consume these datasets using any framework of their choice because we have built readers for Spark, for Pig, etc. All right, let's go back to the GDPR compliance. So, with DALI now we have a way to be compliant. So let's take a data set like the member's profile data set. And using Warehouse, we can get metadata for these data sets. Warehouse lets you annotate these data sets with compliance information. So we can indicate that certain fields are personally identifiable information, such as the member's ID or their name. On the LinkedIn site, users specify their privacy settings. So, you can think of that as, I don't want my profile data used for a certain use case, like ads targeting, or don't share my email address with third parties. That could be another use case. And so for each of these, data set and use case combinations, we kind of store a bit, opt in or opt out for every user. So what you get is each one of these cells gets replaced with a bitmap, and we're storing a bunch of bitmaps for each cell in this table. And this is our member privacy settings. So you take that and you combine it with the metadata provided by Warehouse, and you can feed that into the DALI reader library. And the DALI reader library, which everyone uses to access data sets, can now also do compliance enforcement for us. Depending on the use case, it can do different transformations. Depending on whether an ads user is accessing the data, it can decide to filter out or obfuscate personally identifiable information. So let's take a deeper look at how that transformation library works. When a DALI, DALI reader is used to access a data set, we're executing, a SQL query. And a SQL query can be represented using an operator tree. You can think of it as scanning a data set, applying, a where clause, and then projecting some fields. And so we intercept this operator tree, and then we add our own compliance operator. And into this compliance operator, we feed our metadata. We can figure out which user is accessing this data set and which data set they're accessing. That's the query context. And we take in these privacy settings that the user has specified. And this operator can then filter out any personally identifiable information if there's no business use case for it. So now, putting it all together, how did we leverage Goblin in this pipeline? Well, being compliant is not just about filtering out data at read time. We're legally obligated to delete users' data when they close their accounts. So, we actually have to permanently delete their data. So we take the same system, the same metadata, and we use the DALI reader, and we put that in a Goblin task that uses the DALI reader. We also keep track of which users have closed their accounts. And we also take this into consideration when doing our transformations. We filter out all records belonging to members that have closed their accounts. And in Goblin's case, it actually wants to purge the data. So what it gets out of the reader are only records belonging to active member accounts. Goblin then writes this data out to another location, which is the purged data. And the final step is to replace the original data with the purged data set. And with that, we're now compliant with GDPR, and we have solved the data paradox. And to recap, we did this using a combination of a warehouse for metadata, DALI as our data access layer, and Apache Goblin as a data management tool. Warehouse and Goblin are open source, so we'd like to invite everybody to contribute and collaborate on these. Thank you guys very much. This concludes the Big Data Meetup. Hope to see you guys next time. I'll give it back to Shashanka now.
Great talk, guys. Any questions so far? Eric, maybe you want to come back up? Hi. How do you keep track of metadata from streaming frameworks? Like, what streaming frameworks actually accessing it? And you talk about like a abstract reader, and there is a notion of compromising on the latency part also. So how do you balance it out?
Sure. So with streaming systems like Samza and Kafka, most of the data is stored in Kafka topics, and the retention on those data sets are generally, a few days to a week. And since the data is not retained for more than a week, we don't need to do any special filtering of those. However, the DALL-E reader is general enough to be applied to those use cases. We're working on a DALL-E reader for Samza as well, and that reader could also take in these metadata and privacy settings and do the same filtering in a nearline environment as well. All of this filtering only involves map-side operations, so they can easily be done in a streaming fashion as well.
A quick addition to that, since metadata was also asked about. A lot of Kafka topics are actually replicated to HDFS, and when Goblin ingests them, it actually produces what we call a lineage event, and that allows us to kind of get the mapping of a Kafka topic to a Hadoop data set. And so that allows us to acquire metadata only once on the upstream data set and then propagate it downstream. So you don't have to re-annotate a data set just because it's a copy of the original. Any other questions? Anyone else have war stories to share about data management or data integration? There's a lot of wine and champagne probably still left over. All right, thank you, everyone. And big thanks to all our speakers. We should probably get a quick picture with everyone. But so stick around. We're going to hang out for a little bit for more questions as well. And thank you.
One more time.